Hello, I'm Christian Nicholson. I'm here today to present on a assembly line workstation layout review. I'm from T43, so the assembly line, and I manage the first part of the assembly line, the first third on B shift. I'll take you through a problem that we recently had, and it will follow the method of, or the tool of DMAIC, so define, measure, analyse, improve and control, to talk you through the topic and how we went about looking into it. So to define the problem first, at Rolls-Royce we utilise RFID technology to track vehicles and to send communication signals to our logistics support functions for them to deliver the next car sets to the assembly line and to the specific station that requires it. So each time the vehicle moves, it's got a little RFID tag on it, and there's a network of antennas that reads the movements of these vehicles, and when they move into the next station, that's when it sends the next triggers. Quite often we receive complaints from associates throughout the line of late car sets, late stillages, etc. And that is probably more prominent in station 4010. We get quite often complaints from the associates in that station saying, why is that stillage late? And it seems to be this station more so than any other. So what we thought we'd first do is have a look at the station itself, the work packages. So we did a bit of drift analysis and Yamazuni first to define really what's going on in that station. Can be seen from this graph that through the drift analysis and the Yamazuni that several models even exceeded the attack time. So with the attack time being 34 minutes, which equates to 2,040 seconds, it can be seen that certainly some of the models exceed this, and some even come quite close. So R6 and the Coleman for some of the packages comes very close. So that's one issue. So evidently, if car sets are late, that eats directly into their build time and their cycle times, and where packages, for instance, are exceeding, that could become an issue for them. Overall, however, for that station, the average utilisation is 77.85%, so they do have a bit of flexibility, so in between tacks and in between when the vehicles moves, because we put any number of models down the line, and they do have that option and that buffer to catch back that work. It's not ideal, and obviously we'd like to be at 90% cycle time to attack time, but it can clearly see that there's issues. So their point is valid. If they do get car sets late, this can cause them some issues, and particularly this increases pressure. The increase in pressure has sort of three main highlights that it does for the associate. They can work out process. Someone that maybe thinks, okay, I need to get this done, might think or cognitively perform operations in poor economic positions. They might think, okay, I just need to get it done. I'm not going to do it how I've been shown, or I'm not going to do it how I would normally do it, and how I know how to do it by the standard. I do it by an operation that just gets it done. And this, in doing so, increases the likelihood not only of inducing mistakes, but also on safety to that individual. Going forward, we then looked into the measure phase, so we've analysed, so first found out that yes, okay, the station is overtaxed, but how are we going to address the comment and the issue of the stillages being late? Through system analysis and simulation of the vehicle movements, so there's several different systems. One's IPSQ and one is the mapping tool for the cars and the RFID tags. We found that certainly several instances where they raised concerns that the vehicle would move into station. Here's an example: they were moving to station at 12:21. However, the material request signal that was sent to logistics was sent at 12:22. So albeit it might say that's only a minute in automotive manufacturing is quite a lot. In Rolls-Royce it might not receive that much, but however, when asked through the market of the automotive industry, an average production or downtime costs on average £22,000 a minute. Looking a little bit further into the topic and analysing it, we could find not really there was any systematic failures. So we really had to understand what RFID technology is and how it works. Through literature review, we found that one of the main causes of why RFID technology doesn't work as well is metal. So metal surfaces reflect energy emitted from RFID readers and create interference with the RFID tags, which mean that the tag isn't powered and therefore doesn't transmit information. So with this knowledge, we then had a look at the assembly layout, because we thought, okay, if metal was an issue, how does the layout of the assembly station look in reference to the antenna position and metal surrounding it? So by this graph you can see these green boxes and arrows. This indicates the antenna position and the direction in which it faces. And this area highlighted in red shows all of the storages and containers that are blocking the two antennas point of view, direct line of sight into the station 4010. So therefore, via our best knowledge of the system of RFID technology, we thought, okay, there's quite a lot of storages there. It's specifically been designed because there's a lot of content. So ergonomically, everything's been placed close together, and therefore it's effectively created a Faraday cage and blocking off the RFID signals. Therefore, again, supported by literature review, we thought, or took on the aspect of direct line of sight. Let's work with that as our solution going forward. So therefore, our proposed hypothetical solution would be to move one of the antennas from the wall mounts away from the line directly to a support strut in station 4010, utilising the direct line of sight standard. The positioning of this antenna would be above head height, so ergonomically it wouldn't interfere with the associate, and also facing directly towards the station, so angling it towards it. In review, we've come up with, together via Yamazuni chart, advantages and disadvantages, mainly focused around quality, cost and delivery. What are the quality improvements, what are the cost improvements or disadvantages, and what are the delivery improvements. Specifically on delivery, because it's hypothetical and it's a topic that we're not experts on, it's something that we are utilising our best knowledge and literature review. Some of the disadvantages, we don't actually know it's going to work. We suspect it might do, based on this direct line of sight, and there being no metal surrounding that, the new position and the direction it looks into the layout of the assembly station, but we just don't know. So one aspect going forward, and what we'd like to recommend for improvement and mitigate the root causes further, is once we do this move, I'll provide the RFID antenna position map, document the change of where we're moving the antenna and why we've done it, and then do further simulations. So like the simulations that we've done in the measure phase, with our system analysis, can we perform it again with the new layout design? Some of the other advantages going back to Yamazuni is it's not an intrusive solution. It doesn't have any impact on the ergonomics and the impact of the associate itself, bar the suspected improvement of delivery of the stillage to the line. So positives, no impact associate, which is the main point, and some secondary improvements is not very costly improvement. All it requires is some infrastructure, IT infrastructure, and maybe some brackets, and hopefully that should solve a relatively simple issue. Some final points then in terms of control and mitigating the root cause further. We could look into analysing the positions further. Could it be a solution that we implement an additional antenna, so not only have the new layout, could we go back and add in one or two more antennas around that station? And finally, we identified at the start that the station itself isn't balanced that well. could we balance it a little bit further and maybe reduce content and therefore reduce the amount of stillages in that station to remove the amount of metal, and by that analysis and work going forward, that is another solution in which the layout could be improved.
So thank you very much. I've got a couple of questions. And so stillages are when things are stationary.
The terminology of an assembly stillage or car set is we utilise a off-site warehouse to make up delivery packs for assembly stations, and that is delivered in a stillage or a car set. So it's a wheeled manual handling system that gets delivered on a truck and then gets delivered to the line, and once it's empty and on the next tag it gets taken away and a new one gets delivered.
So are there, when you're assessing this in terms of ergonomics, what types of ergonomic features or concerns or areas did you look into in this particular scenario that you have?
Because it's hypothetical, ergonomics only took, we really mainly looked at how the antenna could be implemented into the station. Where the strut is quite close to the vehicle, and therefore the position of it is quite important. The height of the antenna on the vehicle is positioned on the door, and therefore really to get a direct line of sight, you could argue that the antenna needs to be at that height, so waist height or in line with the door. But we don't want the associates knocking into it and having to move around it. So we thought, okay, what's better? Positioning it higher up, angling it downwards, and that means that they won't have to pay attention to it and duck and weave under it.
All right, so that was considered, but in general you would say this is ergonomically neutral.
Yes.
There is no, but that was assessed,
looked
at, and the decision, I think you stated it previously, was that this would be ergonomically neutral in that respect. And my other just general question then is to do with antennas and environment. So there were previous concerns about mobile phone masts and that, and concerns to health and safety, or health to people near mobile phone masts. So moving the RFID antenna, is that more of a risk to the people working near the antenna?
No. The level of which the level and power in which the radio frequency signals are sent are non-intrusive to humans. So it's not a safety concern.
Okay, that was very good, very clear. Thank you very much.